Hey there, welcome to Galileo's AP STEM. Today we're covering topic 3.4 of the AP Calculus curriculum, so if your mind's ready to function, let's dive into differentiating inverse trig functions. Remember the derivatives of the regular trig functions, how sine of x equaled cosine of x, and for the inverse, you might think that arc sine would equal arc cosine, but sadly, life is just not that easy. For this topic, you're going to need to memorize all 6 derivatives of the inverse trig functions. Looking at all 6 derivatives, we can draw a few parallels. For example, each derivative has a 1 in the numerator and something more complicated in the denominator. Another parallel we can draw is how arc cosine is the same as arc sine, but with a negative symbol. This same concept applies to arc cotangent being the negative version of arc tangent, and arc cosecant being the negative version of arc secant. We can also see that the inside for each trig function is always squared and in the denominator, in some way involved with 1 and sometimes under a square root. So let's put your memory to the test and work on some practice problems. And do not forget that the chain rule still applies to these derivatives, so if the inside function is anything other than x, then it must be multiplied to the derivative as well. Let's start off with arc tan of x to the fourth. Using the derivative rule from earlier, we will start off with 1 over 1 plus the inside function squared. Then, in terms of the actual equation, the inside function would be x to the fourth, and in the denominator it's squared, so that would turn out to be x to the eighth. And we can't forget about the chain. This will be multiplied by the derivative of x to the fourth, which will be 4x to the third. Simplifying this out will give us a final answer of 4x to the third over 1 plus x to the eighth. Let's try another problem. Here we have to find the derivative of arc sine of x over 2. And don't let this limit notation fool you, it's just telling you to find the value of the derivative at x equals 1. Now if you remember the derivative of arc sine, you would know that it's 1 over the square root of 1 minus u squared. The absolute key distinction to make is how in arc sine in the denominator, you subtract the u squared, but in tangent you actually add it. I'm telling you, this is very easy to mess up, and doing these practice problems helps clear out these confusions so you don't mess it up on the test. Now let's go back to the problem. Applying the derivative rule to the actual function, we will know that we have to put x over 2 inside of the denominator under the square root, and then we square it. X squared is x squared, and 2 squared is 4, so we will get x squared over 4. Now that we're done with the main part, we can multiply by the chain, which is the inside function, being x over 2. And if you view x over 2 as 1/2 x, then you will know that the derivative is 1/2. We then multiply the 1/2 to the main part, which would give us a 2 in the denominator, so our final answer would be 1 over 2 times the square root of 1 minus x squared over 4. Now remember, the question didn't just ask us to find the derivative, they want us to find the value of the derivative when x equals 1, so we have to plug that in. Plugging this into x squared in the denominator, we would get 1 over 2 times the square root of 1 minus 1 over 4. And look at the denominator, 1 minus 1/4 is 3 over 4. We can actually rewrite the square root as the square root of 3 over the square root of 4. And as we know, the square root of 4 is 2, so we would get the square root of 3 over 2. Remember, we also have a 2 inside the denominator, so we would multiply this together to give us 2 times the square root of 3 over 2. And would you look at that, it cancels out. Now all we have to do is flip the expression, and that's our final answer. If you know how to do problems like these with all 6 derivatives, then you're well on your way to a 5 in the exam. I thank you so much for watching, please subscribe, and I'll see you in the next one.